Okay, so for this problem, we have an array called coordinates. Each entry in coordinates is a list of two elements, so it's got an x and a y value. So we will want to check if these points make a straight line. Okay, so how would we do this? I guess the main thing, and just thinking about lines in general, is if you want to know all the points on a line, all you need to know are the slope of the line and one of the points on the line. And this is a fundamental theorem that you would prove in a linear algebra course. So I'm not going to go into like the fundamentals, but intuitively it makes sense. And you can imagine how you would get to any other point. Like if this is your this point is like called x, y, then for any other x value, you would just figure out how far, let's say this is x0 and y0. So if you're given any x value, x, then you would figure out the distance from x to x0 and use that combined with the slope. You would like multiply those together and add that to y0 to get the y value. And you'd have to account for sign depending on whether the value of x is to the left or to the right of x0. But yeah, so that's basically how you would define any other point on this line. So you can get all the points on the line. Okay, so the two things we need to define a line are the a point on the line and the slope. Okay, so now let's think about this list of coordinates that we have and what sort of strategies we could use. So what we can do is we're going to want to know the slope of this line, assuming that it is a line. And so you could get that by finding the slope between the first two elements of this list. And so then you have that slope. And so we could imagine sort of a strategy where if we have like 3 points here, I'll call them P0, P1, and P2. Then we can define two lines, L1 and, I'll call it L0 and L1. I'm doing indexing starting at 0. So we can define two lines. Line L0, which goes between points P0 and P1, and line L1, which goes between points P1 and P2. So if we want to check if L0 and L1 are the same line, they need to have the same slope, and they need to have at least one point in common. And so we know that they do have a point in common, and that point is P1. And so then all we need to check is, are the slopes of L0 and L1 equal? And so basically what this means is that like if we start with P0 and P1, we can get the slope there. And then for any third point, all we need to do is find the slope between that point and P1 and compare that to the slope between points P0 and P1. Because if it's the same slope, then we know that these two lines share a point, and so then it will be the same line. Okay, so given any 3 points, all we need to, given 3 points, all we need to check is that the slope of the line between point 0 and point 1 is the same as the slope of the line between point 1 and point 2. And if they are equal, then these 3 points lie on the same line. And then you can imagine basically what we could do is we could loop through this list and check for each pair of, we can always use P0 and P1 and use the slope there, but then we could compare that, we could do this test where we compare the slope from P0 to P1 to the slope between P1 and P2. Then we could compare that to the slope between P1 and P3, compare to the slope of P1, P4, etc. until we get through all of the points in this list. So that's going to be our approach, is that we're basically going to loop through points. We're going to start with the point at index 2 and loop all the way to the end of the coordinates and check if the slope between that point and the point at index 1 is the same as the slope between the point at index 1 and the point at index 0. And if they all end up being the same, then everything lies on the same point. But if at any point you get a different slope, then, so I should be careful about that word. If at any step in this process you come across a point that gives you a different slope, then you found a single point that does not lie on the same line as the other coordinates, and so the whole thing will evaluate to false, because we need to check if all the points make a straight line. So all you need is for one point to not be on the line, and this will fail. Okay, so how are we going to go about doing this? So basically what we need to do is given pi equals xi yi, we must check if the slope between points 0 and 1, and I'll just say well, no, I'll keep it general. Well, no, let's say I is 0, 1, and 2. We must check if the slope between points 0 and 1, okay, so what is the point going to be? It's the difference in the y values divided by the difference in the x values. So that's y1 minus y0 over x1 minus x0 is equal to the slope between points 1 and 2. So that would be difference in y values, y2 minus y1 over x2 minus x1. That y does not look like a y. Okay, cool. So this is what we must check. But there's sort of two issues here. There are some edge cases we're not thinking about. And you can sort of get a hint of those edge cases because of the fact that we have potential zeros in the denominators. And if we have zeros in the denominators, that means that like two of the points have the same x value, which means that this would be potentially looking at a vertical line. And then, this process would work if we're thinking about horizontal lines, because you would just look for zeros in the numerators. But basically, instead of having to so basically what we would need to do if we wanted to use this equation is that we would first need to check okay, do we have any of the x values being equal to each other? And if so, then we're potentially dealing with vertical lines, so we need to compare the y values. And if not, then we go to this condition. It would be nice if we can check everything at once using a single equation. And so to come up with that, let's just think could we do something where we just take this equation and the issues with this equation come up when we're dividing by 0. So could we eliminate that? And sure. Let's try it out. We could check if, and then let's just multiply this out. So this would be x2 minus x1 times y1 minus y0 equals x1 minus x0 or y2 minus y1. Right, because if this equation holds, then this equation holds. And so the slopes of the two lines that we're talking about are the same. If this equation is 0, then either x1 equals x2, in which case we need to check if one of these things on the right here is 0. And so if x2 equals x1, if x2 equals x1, then in order for all three of these points to be on the same line, so if x2 is x1, then x2 and x1 are on a vertical line. So if this on the, how could it be the case that these 3 points lie on the same line, but it's a vertical line? Or rather, how could they all lie on the same vertical line, but x1 and x2 share the same x-coordinate? Sorry, how could they all lie on the same line if x1 and x2 share the same x-coordinate? The two possibilities are either it is a vertical line indeed, and so all the x values must be the same, and in particular x0 must be equal to x1. So that's one possibility. The only other possibility would be is if points P1 and P2 are equal, in which case if points P1 and P2 are equal, then y2 equals y1, and so this would be 0. And so if these 3 points lie on the same line and x2 equals x1, then one of these two things on the right-hand side are going to be 0. So, therefore, if the 3 points lie on the same line and this first term is 0, yeah, I'm getting a little, it's a little tricky to go through this exercise because we have to keep in mind like what direction, like what is the order of the assumptions and the things that we're trying to prove. So let me write out a proposition, and I think this will clarify where we're going. Given Pi xi for I equals 0, 1, and 2, if x2, x1, y1 minus y0 equals, and I'll continue on the next line. If this equals x1 minus x0 times y2 minus y0, then the points lie on a line. Okay, proof. And I'm going to define this as M. So M is going to be defined to be equal to this thing. Okay, so we have case 1 in which M equals 0. If M equals 0, then this this product equals 0 and this product equals 0. So I'm going to write this out in a chart like this. And then y2 equals y1. Okay. So if m is 0, then let's see here, we have these two statements. One of these two has to be 0. Yeah, either x2 equals x1 or y1 equals y0. And so that's why here we're saying at least one of these is true. Then similarly, on the other hand, this product is 0, so either these two are equal or these two are equal. So one of these two equations is going to be true, or possibly both. But that's actually not going to be the case ever, and we'll get to that. But basically, if let's just consider all four possibilities here. This corner, x0 equals x1 equals x2, so this must be a vertical line, which is indeed a line. And so then everything lies on the same line. Here, y0 equals y1, which equals y2. So this is a horizontal line, which is indeed a line. Okay. Here, the x and y values for points 1 and 2 are the same, so p1 equals p2. And here, the x and y values for points 0 and 1 are the same, so p0 equals p1. Now in the problem statement, it says, coordinates contains no duplicate point. And so we're not going to have to worry about these edge cases. Okay, so this confirms the proposition for the case of m equals 0. Because if m equals 0, then either it's going to be a vertical line or a horizontal line, in which case it's a line. Okay. So now we have to consider case 2, in which m is not equal to 0. Then what we have is, no, we don't want to call this m. We want to call this something else. Let's call it alpha, because it's just not really related to anything else. So if alpha is 0, here. If alpha is not 0, then here, if alpha is not 0, then x2 minus x1 is non-zero, and x1 minus x0 is not 0. Because if either of these were 0, then alpha would be 0. So what we can do then is we can take this equation and put x2 minus x1 in the denominator here, put x1 minus x0 in the denominator here, and then what we get is we get y1 minus y0 over x1 minus x0 equals y2 minus y1 over x2 minus x1. So lines L0 through points P0 and P1, and line L1, which goes between points P1 and P2, share the point P1 and have the same slope m. we'll define m to be equal to this thing. So they are collinear. Collinear? That's the right word, right? They lie on the same line. Okay, so basically, this proves that if we have 3 points, we just need to verify this equation for those 3 points. And so then what we can do is we can fix P0 and P1 to be the first 2 entries of coordinates. And then for P2, we can just loop through all the others, and for every point, we just check this equation. Okay, so let's do that. So basically what we would do is we'd start with x0, y0. And by the way, coordinates has at least 2, coordinates has at least 2 elements, so this will be fine. So we get the x and y coordinates of the first point, and then we get the x and y coordinates of the 0th point, and the x and y values of the first point, or the coordinates of point at index 0 and point at index 1, whatever you want to call it. Okay, so then for I in range, we're going to go from 2 all the way to the end of the list. And so we want to check all of the other coordinates. So we want to include the final entry of coordinates, and the index of the final element of coordinates is precisely the length of coordinates minus 1. And because range does not include the last value, this is exactly what we want. Okay, and if there are only 2 coordinates, then this will just not run at all, which is what we want. Okay. Oh, I guess I'll come back to that, but yeah. Basically we just check if x1 minus x0 times, oh, no. First we need to get the x and y coordinates of point I. And now we check if x1 minus x0 times y minus y1 is not equal to x minus x1 times y1 minus y0, then we return false. Because what we need is for this equation to be true for every triple of points that we get. And if there's ever 3 points in these combinations of points, if there's ever 3 points where this equation does not hold, then we can form 2 lines from this list of points that do not lie on the same line. And so we return false. But if we're able to make it all the way through the list, then we return true. And if there were only 2 entries in coordinates, then this entire clause would be skipped, or this entire block of code would be skipped over, and it would just return true, which is what we would expect, because you can, by definition, form a line between 2 points. So yeah. The only other thing that we could do is if we really wanted to optimize this as much as possible, we see like x1 and x0, the x1, x0, y1, and y0, these are fixed values. So we don't need to do this subtraction every time. We could just do this subtraction once up here, do it here. And in fact, just to be completely explicit, I'm going to write it like this. And then we could also do y1 minus y0 This is sort of like an odd naming convention, but the point is to just be completely explicit in what this is. And so basically you just do like this is really sort of splitting hairs here because addition and subtraction are such quick operations. But if you really wanted to optimize this as much as you could, you only have to do this subtraction once, and then you could store it and use it in every single loop rather than evaluating that every single time. But yeah, let's just run it and just make sure that I didn't do anything wrong, and I didn't do anything wrong. So yeah, a little bit of math at the beginning, but otherwise, there you go.